We are recording.
Hi, this is Paula Gloria with Rabbit Hole Central TV, and I'm here at one of my very favorite locations, which is the Patterson Homestead in Dayton, Ohio. And I'm also going to introduce to you one of my very favorite guests that I've ever had, and that is Robert Patterson, Robert Wagner. I'm thinking about the Patterson Homestead, because John H. Patterson was the man who started National Cash Register, and Molly and I are going to be doing a lot of work about binary economics and capital ownership, and how corporations, we need to sort of revamp the corporations in America, make this country stronger. And that's why I'm excited about Bob Wagner, because he's been known as the internet skeptic, and he's been taking exception to the science behind man-made global warming. So I'm going to now turn this over to Robert Wagner, and we're going to learn about what's really going on with global warming. So thanks Bob, for coming here to make this presentation.
All right. Well, thank you, Paul. Paul was one of the people instrumental in helping me get this up and running and getting a great deal of publicity. So I can't thank you enough. You've done an absolutely fantastic job getting this message out, and I can't thank you enough. You too, Molly, Rock, and Dave. This is a new. Many of you have probably already seen the presentation from a few years ago. Well, this is a more updated version. Been giving it probably for about the last 6 months or so, and I hope you enjoy it. But what we're going to do is, right, you keep hearing about everyone wanting to cut off the conversation. We need to jump into action, right? The debate is over. Well, that's why I created this presentation called Global Warming Dialogue, because I think you're going to see that the debate's not over. The science certainly isn't settled. And we're going to open up a conversation so we can actually take a look at the science. Well, I'm not going to tell you what to think. I'm going to give you that you can make up your own mind. I'm not interested in making your mind up for you, but I want you to think through these ideas, these concepts, this science, so you can make up your own mind. So for about the next 45 minutes, I want you to forget what you've been told. I know what you've been told. I believed it at one time until I started looking into it. I actually was creating, how I got into this was creating a presentation so I could teach cause and effect. The whole theory is that increase in CO2 increases temperature. And so I said, okay, that's a great science experiment. I can give a science lecture on that. And so when I started trying to make the case, I found out there is no case there. Right? So what I want you to do is I want you to open your mind and I want you to think for yourself. Okay? One of the things I want you to think about is when you're looking at the science, remember that the scientific method is universal. Okay? The whole theory is that an increase in CO2 drives an increase in temperature. So, you're back in science class and you always hear about these independent and dependent variables, y equals mx plus b. Well, what exactly does that mean? Well, in this model, you have CO2 is your independent variable. It's going to change. Man's going to change it. And then the dependent variable, what depends upon the change in CO2, is the temperature. And that's their whole theory. Well, once they do that, that's a scientific experiment. You don't need to be a climatologist. You just simply need to know the scientific method to determine whether or not that's valid. And so that's what we're going to do. We're going to take a look and see, is that a valid model? Okay? And also remember that the mathematics is the science mathematics is the language of science. And we're going to take a look at the mathematics. We're going to take a look at the science, and we're going to take a look at this modeling, and we're going to let you decide, does it make any sense? Okay? People often ask me, well, what do I know about this kind of stuff? How do I get involved in this? Well, one of the main reasons I got interested in this is because I do have a financial background. Climate models are essentially edited financial models. The original climate models were financial models. They just plugged in the temperature data. And I do a great deal of financial modeling. When you take a look at Wall Street, all those brokerages, they have highly complex models of the S&P 500 or basically the market indices. Okay, and so that's how all this got started. So if you understand how to model something, a highly complex things like the stock market or whatever, you understand how all the science works and how to create these climate models. Okay? And here's one, basically, I throw this one in just because one of the major critics of the global warming science is this guy named Steve McIntyre, and his background is economics and finance, which is the same thing mine is, and he has found major mistakes made by NASA. And you can see he was the one who disproved the hockey stick chart, and he's also the one who caught the most recent error by NASA where they included the Russian data twice. They included the summertime data and the wintertime, and that's been the two major mistakes NASA's made. It was both caught by this Jim Hansen guy from up in Canada. All right. The first thing is you're being told that there's a consensus. Yes, there is a consensus, right? We all know that, That's what we've been told. Everybody's saying it, and we've got to close off the debate. Well, if you take a look at that, you'll see that there really isn't a consensus. And how in the world would you determine a consensus anyways? This is a report from the U.S. Senate Minority Report. More than 650 international scientists dissent over man-made global warming claims. Scientists continue to debunk the consensus in 2008. Now, that's not me speaking. That's the U.S. Senate. Okay? There's also something called the Global Warming Petition Project. And you can see that over 31,000 scientists have signed it, saying that they disagree with the IPCC. And the other thing that I find kind of curious about this consensus is if there's such conviction to the science, you would find people out there debating it like I'm trying to do all the time. But what you see is the people that really believe in this, they won't debate it. Matter of fact, it's to such an extent where they're out there offering Al Gore $100,000 to debate this issue, and he turns it down. Now, if you really believed in something, would you ever turn down $100,000 just to get your message out and to defend yourself? I certainly wouldn't. And I tell you what, Al Gore, if you want to give me $100,000, let's bring it on. We'll take it on. All right? But I would argue that there is no consensus. And more importantly, what exactly is the consensus on? Is it on their models? Well, temperatures have been falling since 1998. Does anyone honestly believe that back in 1998, if there was a consensus, that they all thought that the models would be saying that temperatures would be falling over the next decade and continuing to fall? So if there is a consensus, it's on a very bad model, because the model certainly isn't explaining what you're seeing today. Just look outside. Right? Here's what you find in Prada just this week. Okay? Earth is on the brink of a new ice age. If you really take a look at the data, it looks like we're rolling into the cooling phase, not a warming phase. In fact, like I said, temperatures peaked back in 1998. Okay? Here's another example. This is the National Registry of Environmental Professionals. You can go take a look at this on the website, and once again, they show no consensus. You've got 59% respond to say that climate activity exceeds normal calibration, but that's nowhere near a consensus. So I would say if you take a look at this, first find out there's a consensus on what? That there's warming? Well, if there's warming, like I said, we're cooling over the last decade. And if there's a consensus on the models clearly aren't telling, describing what you can see just by going outside. Here we have the science isn't a popularity contest. And they keep saying there is a consensus. So what, even if there is a consensus? Okay, there's a consensus on Y2K was going to cause these major disasters. There's a consensus on silicone breast implants. There's a consensus that there's a flat earth. Okay, consensus doesn't make good science. Okay, if you get a bunch of people all to agree on something, it doesn't define reality. It just means that they've agreed on something. And getting a consensus from a bunch of climate scientists who believe in global warming, that's like going into the Catholic Church and seeing if there's a consensus. Did Jesus exist? Okay, of course they're going to say so. So who are they polling to find out what this consensus is? They certainly are polling people like me or the people who have actually looked at the science. Okay. Let's take a look at the facts. In this presentation, you may have recently seen Barack Obama, and he gets out there and he's talking about the climate science convention that they're having between all the governors, and he outlined very clearly what exactly is the position of people who support global warming. He says that there are few challenges more urgent than global warming. Okay? I think anyone who's walked outside, at least right now with this record-setting cold, might have a little disagreement with that. So science is beyond dispute. We got to stop this conversation. We got to stop people like me talking about this stuff. Okay? Sea levels are rising, coastlines are shrinking, the facts are clear. Okay? Record-spreading drought and famine. Okay? Storms are getting stronger with each passing hurricane season, and denial is no longer an acceptable response. Okay? That's what you're being told. Would anyone here disagree with that? We've all heard that. Okay? Watch Al Gore's Inconvenient Truth. It's all covered. Okay? Well, what's nice about it is someone's done exactly what I've done. And if you go to the Telegraph UK, President-elect Barack Obama proposes economic suicide for U.S. And in this presentation, or in this article, he goes through and takes every single one of his points, and he disproves it. He basically says these are the facts. And that's essentially what I've done in this presentation, and you're going to see. And you'll be able to judge for yourself. Are people like me and the author of this article telling you the truth, or is Barack Obama telling you the truth? Here's just a couple articles. I throw these in so that you can go, if you get the presentation, you can go look them up. But this basically just covers the same thing about how, they're pressing. We've got to do something about global warming. Okay? Here's just basically says the case closed. The debate on global warming is over. They're doing everything they can to shut down debate. Okay? And that's what we're not going to do. We're going to have a conversation. We're going to make sure we cover it. Okay? So the way I came about doing this was I went and grabbed all the science and all the charts and the data, and I just simply removed the axes from it so you don't know what we're talking about here. This could be a chart of anything. This could be the Dow Jones Industrial. Okay? And I'm just going to simply ask basic questions on this chart. Okay? I have certain peaks, 1 through 5, and there's a letter A over there. Would anyone in this room tell me that A is above those previous peaks, 1 through 5? If I take a look here, this is the current level of whatever this is, and these are all previous peaks. Would anyone say A is above that level? No, I think anyone would say that's below it. Well, what is that I'm just showing you? That's a temperature chart that Al Gore uses in his own movie. If you remember, this is the scene where he gets on the forklift, he goes up, he says, CO2 is going up here. What he forgot to tell you is that he also has temperatures down here. Okay? He has CO2 and temperature. He only addresses CO2, and the reason why is because what you just told me, temperatures aren't at record levels. This is a chart from his book. And as you can see, while CO2 is racing to all-time highs, temperatures, according to Al Gore's own chart, were falling. This record high CO2 barely even caused a blip in the temperature chart, according to Al Gore's own chart. Now, once again, getting back to cause and effect, if you have CO2 driving temperatures, wouldn't you expect record high CO2 to drive temperatures to record highs? Yet they don't. And that's according to Al Gore's own chart. His own chart, if you know how to read it, totally disproves his own theory. Okay? The other thing is, if you're going to have a model, you have carbon dioxide and you have temperature, you'd have to, if you're going to have a consensus on it, you'd have to have a consensus on what data set you're going to use. It makes no sense at all to sit there and say you have a consensus if you don't even have a consensus on what temperature is. Well, if you take a look here, you have temperature charts all over the place. And as you can just imagine, if you take this data set, plug it in a computer model versus this one versus that one, you're going to get totally different values no matter what. So how can you have a consensus if you don't even know what temperature is? The IPCC themselves don't even know what temperature is. This is the IPCC back in 1999. The IPCC is the International Panel on Climate Change, Intergovernmental Panel on Climate Change. I'm sorry. Okay, this is the temperature chart that they use in their first report. This is the temperature chart that they use in their second report, and this is the temperature chart they use in their third report. Now, explain to me, how can you have a consensus when you don't even have a consensus on the data that you're using in these models? It makes absolutely no sense in any normal kind of science. Okay. Al Gore himself doesn't even know what a temperature chart is. This is his own movie, and he uses 2 different temperature charts, as you can see, in his own movie. So what kind of science allows you to pick and choose what chart you use to make your case? You can make any kind of argument you want using the science that's coming out of these people. Okay? Hey, here's just another thing about how the IPCC basically has lied about the temperature, and they're making the same case I am. I mean, you got to have good data to have a good model. Okay? Here's the inconvenient truth. I'm just highlighting how he uses different charts in his own movie. Okay? Here's just for a repeat, IPCC 1990. This is the temperature chart. This is the temperature chart in 2001. This is a famous hockey stick chart. Okay? And here it is in 2007. So you can believe there's a consensus, but I can tell you they don't even have a consensus on the data. The other thing that there's no consensus on is they keep telling you about global warming. Well, if you take a look at their own charts, their charts don't show global warming. This is the chart, northern hemisphere, or the globe, northern hemisphere, southern hemisphere. And what you see is you don't have southern hemisphere warming. You actually, in some of this data actually shows that you have southern hemisphere cooling. So you can't make the claim that you have global warming. You can possibly make the claim that you have northern hemisphere warming. But once again, CO2 is all the way around the world, evenly dispersed. How could CO2 cause warming in the northern hemisphere and not the southern hemisphere if it was the cause? Okay. All right, now this is Dr. Paturi. This is a lead man at the IPCC, International Government Panel on Climate Change. And what is he saying? What's he telling you? He's telling you that we're at a stage where warming is taking place at a much faster rate than ever before. Right? You've heard that 1,000 times. And he shows a chart. For the past decade, it represents temperatures climbing sharply. Now remember, decade and climbing sharply is what he's telling you. Well, guess what? I've got a chart here. And it goes back a decade. And here's the level back a decade ago. This is the moving average. And here's where we are today on this chart. I don't know what this chart is measuring, but as you can see, it measures something. This is a decade ago, and this is today. Would anybody in this room describe this as A, sharply increasing, B, sharply decreasing, or C, staying flat? Is it a sharply increasing chart? Is it a sharply decreasing chart? Yes. Okay, yes. Well, guess what this is? What did you just tell me? You just told me that temperatures aren't rising rapidly over the last decade. You just told me that temperatures are actually falling. Okay, because that was simply the temperature chart. And as you can see, 2008 will be the coldest year of the decade. Now, how in the world does the IPCC reach the conclusion that we're sharply increasing when we're actually setting a decade low in temperatures? Here's the chart. And as you can see, this is 1998, and that's today. I would describe that as sharply falling. More importantly, if you take a look at that level, that's today's level. It's back below where you were in 1979 when they were telling you there was a coming ice age. I didn't make that chart. That comes from NASA. Okay? So what you've told me is that over the last 3 decades, there's been no warming. We're below where we were 3 decades ago. Okay? Here's basically the same chart showing the same thing. Okay? All right, well, we just took a look at temperature. Temperature being the dependent variable. Let's take a look at the independent variable. Well, this is the famous chart you see of CO2. We've all seen this. Have you ever seen Al Gore's movie? This is CO2. One couple of interesting notes about this is, first, you see how this is white and then it turns yellow over here? It's nice and smooth and zigzag. Well, all data back before about 1955, this comes from ice cores. This comes from a flask sample on top of Mauna Loa. Okay? So it's not a continual data set. They piece things together. That was my first thing. That kind of caught my eye. Right? So what you got here is you got direct or proxy. A direct measurement is when you take a measurement directly from something, or a proxy is when you use something to kind of represent what you're measuring. Well, what they do here is, this is one measurement technique. You drill an ice core. Now remember, this is sea level. Sea level, they drill an ice core, they bring it up, and then they pull CO2 out of the ice, and they say, okay, that's approximately what it was in the atmosphere. Okay? Now this is a direct measurement. We got these guys on Mauna Loa, which is a volcano. Probably spews a lot of CO2, by the way. And they go out and they take a flash data, they clap it down, they go and they measure the actual CO2 in the atmosphere. Okay? So those are 2 different measurements. But does it make sense to combine those type of data sets? Okay? One's at sea level. One, you're drilling down below sea level, and you're pulling ancient air out of ice and hoping that the CO2 hasn't changed over thousands of years. And the other one, you go get a direct measurement right out of the air. But that's what they're doing. That's what they're telling. And they're going to bet everything on that kind of science. Okay? Okay? The obvious question I had was, okay, if you're going to do that, why didn't you take flash data from Antarctica? I mean, why go all the way to the North Pole to do it? Okay? And why don't you combine those data sets? But they don't. Well, the reason they don't do that is, guess what happens if you do take flash data? Okay? This is what you get when you get flash data. Okay? And as you can see, this is ice core CO2, that basically straight line, and this is flash data CO2. Okay? If you measure it using flash data, you're nowhere near an all-time high in CO2, which Al Gore shows you. Okay? But that's what he wanted. If he found the data set that showed record high CO2, and so he uses the ice core. Okay? Here's just a cleaned up version. As you can see, this is back in 1940 where CO2 was much higher. 1820 CO2 was much higher. And over the current level, we're in the middle range of the range. That doesn't make you too alarmed, right? So you just throw that data set out. Okay? But once again, and this goes back even further, you can see CO2 was even much higher, depending on what period you use. Going back to the cases, once again, if you don't even have a consensus on what CO2 was, how can you have a consensus on what the model is? Okay? Now, this is when I give the live presentation, I normally give these slides out, and I ask people certain questions about them, like I'm showing you here. So you use this slide to answer some of the further questions. And what this is this shows the IPCC's description of the different greenhouse gases and things that cause global warming, and the level of understanding. So over here you have a great deal of understanding. Over here you have very little understanding. Right? Things you want to point out here is CO2. There's a great deal of understanding, and it contributes a great deal to global warming. Over here you have solar. Okay? Very little understood about it, and they're saying it causes very little global warming. Okay? All right. Well, here is a chart. Once again, I'm not going to tell you what this chart is. I'm going to let you decide. And I have something labeled 1 through 5. And these are the atmospheric greenhouse gases. You don't know which greenhouse gases they are, but I have them labeled 1 through 5. Down here at the bottom, this is total atmospheric absorption of infrared. So this is the greenhouse gas effect, right? You take all these different greenhouse gases, you sum them up, and you get here. Now, if I look here and I ask you which one is the most significant greenhouse gas, is anyone in this room going to say A or number 1? Does number 1 look like it matches this pretty closely? Anyone going to say no? How about number 2? Does that look like a significant greenhouse gas? No. How about number 3? 4? 5? Yes. Okay. I think most people would say number 5 is by far the most significant greenhouse gas, right? I mean, you got these 2 little peaks, 1 peak, 2 peaks, and a lot. Basically, it overlaps here almost totally. Okay, so if these are greenhouse gases, what is number 5 then? This is the most significant greenhouse gas. What is it? What's Al Gore telling you? What's Barack Obama telling you? What's that greenhouse gas?
Carbon dioxide.
Carbon dioxide, right. Wrong. Okay? Guess what that is? That's water vapor. Water vapor is by far the most significant greenhouse gas. Right? Did you even know water vapor was a greenhouse gas? Did you know that it was by far the most significant greenhouse gas? Water vapor, if included in the calculations, is responsible for well over 95% of all the greenhouse gas effect. Right? The only way CO2 becomes the most significant is if you just simply ignore water vapor. Then it becomes the most significant of the insignificant greenhouse gases. Okay? They don't bother to tell you that. Al Gore is never going to tell you that because it totally disproves their theory or ruins their case. The other problem they have with CO2 is, remember how we had those couple peaks? Well, this is water vapor and CO2 overlapped. The problem is those peaks of CO2, they overlap water vapor. So even without CO2, that part of the infrared spectrum would be absorbed. The only part that isn't absorbed by water vapor that is unique to CO2 is this little area right here and that little yellow area over there. That's it. That's the entire greenhouse gas contribution of CO2. Okay? In reality, it's the part that's out at 15 micron that really matters. It also overlaps with water vapor. So all of this global warming, man-made global warming argument comes down to this little chart right here. This slight amount of the infrared spectrum that's not overlapped by water vapor. And remember, basically it's this little tiny pimple on that entire spectrum. And man produces 5% of that. Does that seem reasonable? Does that small little bit does that seem to be the type of thing that could change climates and destroy the earth? But that's what their whole argument is. That little bit, that little sliver. All right, well, let's take a look. Here I have some more charts. Chart A, chart B. They look pretty similar. I mean, I make the chart and I have trouble with what they are. Okay. Well, guess what these are? This is water vapor. This is the temperature grid of the globe, and this is the atmospheric water vapor. And as you can see, they overlap almost identically. When you put them one versus the other, they're almost exact. Right? So if I told you that, since we all can agree that water vapor is by far the most significant greenhouse gas, I'm going to go back to this chart. Remember, this is a chart that the IPCC says defines global warming. They understand it a great deal, and it causes a lot of warming, or they don't understand it at all, and it causes no global warming. I know it's a little bit small, but can anyone show me where water vapor is on this chart by the IPCC? I've looked for years, and I can't find water vapor anywhere. So it's very easy to make a case that CO2 causes global warming if you just simply ignore water vapor. You just basically, in some kind of Orwellian fashion, write it off. All right? There's water vapor nowhere on this chart. Now, how could the IPCC be telling you that CO2 causes global warming if they don't even understand about water vapor? And once again, that's their chart. You can go get it yourself. And that's no joke. The other thing is, when you take a look at, when you talk about global warming, you talk about something called a global warming potential. So I thought, okay, well, what's the global warming potential of water vapor? If I'm going to have a model that includes all the greenhouse gases to explain the temperature changes, I would need to know what the global warming potential of water vapor is. If I know all these other global warming potentials, I would need to know what the potential of water vapor is. Well, guess what it is? A big old Na. That's like me doing a scientific experiment on weight loss and not including caloric intake and exercise. They just ignore the most significant variables out there. They literally put Na when it comes to the contribution of water vapor. And yet they have a consensus on that kind of a model? All right, here's the other thing. Going back to Science 101, and when you have calculus, you always hear about these derivatives and all this kind of stuff. Well, here's a great little calculus problem so you can actually understand what your professor was telling you about. All right, well, calculus is basically just a derivative is just a fancy word for a slope, and it ties the relationship of one to the other. Well, here you have the rise and the run. This is the model as temperature and CO2. And this is how you would test a scientific experiment. You'd sit there and you'd find the relationship between them. Well, the rise goes from here to here, and that line is flat, so the rise is what? 0, right? Carbon, the run, goes from about 320 to 370. It comes out to be about a 15% increase. So the relationship would be the rise over the run. So what's the relationship if you have 0 divided by 15? 0. The relationship between CO2 and temperature using their own data is 0. And yet you're being told CO2 drives temperature. This is just something I throw in there to show you how important water vapor is. If you go to this website, it's Antarctic Weather, they explain, because the reason I stumbled upon this one was I was saying, okay, how do you do a normal experiment? You have controlled and you have an uncontrolled, so you can compare two samples, right? And I was trying to think, where could I find somewhere in the world where you have an amount of air with water vapor in it and CO2, and within a relatively close proximity, air with no water vapor and just CO2. So I had two samples. One had CO2 and water vapor. One had just CO2. And I wanted to see what would happen to the temperature change between those two, right? Because you would think if CO2 was the cause, the temperature change would be the same in both samples of air. If it was water vapor, there'd be a dramatic change between the temperatures of the air. Well, you can find that down in Antarctica. What happens is the air comes off the ocean. It's very wet and very warm. As it goes across the land, all the water vapor falls out and leaves very dry air, like you have right now out in the winter, and it gets very cold. Right? You still have CO2, but because you pulled the water vapor out, temperatures plummet. And that's literally how they describe it. They explain to you why, as you go inland, it gets so cold in Antarctica. It's because the water vapor falls out. That's their own description. So they understand water vapor is the most significant greenhouse gas. They understand the heat trapping principles. Just no one tells you about it unless you really go digging for it. Okay, the other thing is a differential equation. You always hear that term. What the heck does that mean? Well, they're measuring the changes of differentials, changes or differences between things. Well, as I said before, there's no change in CO2 around the globe. It's all 380 parts per million all the way around the world. So how can you have warming in the northern hemisphere versus the southern hemisphere if CO2 is a constant? It makes no sense. Right? So if you take a look here, you have temperature higher in the northern hemisphere than the southern hemisphere. But what do you have a difference in? Precipitation is much higher in the northern hemisphere than the southern hemisphere. That's your differential equation. You have a difference in water vapor between north and south, and you have a temperature difference in north and south. You don't have a difference in CO2. The greening of the north is real and caused by climate change. You can see that what's going on is as we get greener in the northern hemisphere, we produce far more water vapor. Trees are the ones that create the most water vapor, and that's why we've been warming. Right? And this is basically just shows the chart of CO2, how it's evenly distributed all the way around the world. Okay. Greenhouse gases warming North America unevenly. Okay? He says greenhouse gases warming North America unevenly. How could that be if CO2 is a constant? Why would there be differences in temperature? Okay. And here's just basically a global CO2 tracker. They're actually figuring out ways to track CO2 around the globe. And as you can see, it's all over. It's changing all around the world. Here's what's called the ARES, the Atmospheric Infrared Sounder, and it basically is just another demonstration of what they're doing. They're trying to track where does all the CO2 come from. Not real important. Okay, here's one more thing that goes back to the modeling. from a modeling perspective. One of the things that they work into these models is what's called an atmospheric lifetime. They claim that the longer a molecule is in the atmosphere, I guess the more infrared it can absorb. So they come up with this important thing called the atmospheric lifetime. Once again, it comes from the IPCC report. Okay? Now, if I'm going to claim that this is highly important, that this is a major factor, wouldn't I want to know pretty close what the atmospheric lifetime of a gas is? Right? Well, if you take a look at the IPCC report, their estimate of atmospheric lifetime is between 50 and 200 years. Now, don't you think your model is going to give you wildly different results if you use 50 years versus 200 years? I've seen other studies showing it between 5 and tens of thousands of years. So once again, how can you have a consensus when you have such huge variations in just the things that you're using in your models? All right, well, let's take a look here. Here's, you've always heard the term correlation. Well, what exactly is correlation? Correlation is how two things go along together or they trend together. And once again, I have a chart here. I'm not telling you what it is, but I have something A is being measured, B is being measured, and C is being measured. All right? I'm going to move C up just so you can see the relationship. Now, from the audience, which two of these would you say is most highly correlated? A and B? A and C, and B and C. Okay? Which two seem to be overlapping quite a bit, and which ones do not seem to overlap at all, or go along together at all? A and B, clearly. I mean, they're almost identical. Okay. So if A and B are, what exactly is that? Well, guess what? That's the solar radiation. Solar radiation and temperature, global temperatures, go along very well. Should that be a surprise to anybody? I mean, all you got to do is walk out on your porch, watch the sun come up, and I guarantee it gets a whole heck of a lot warmer. Okay? Solar radiation and temperatures are very tightly correlated. CO2, it's almost linear. There's almost no relationship at all. Okay? And they know that. I mean, you can find it. They have studies all over the place. Solar magnetic cycle length and temperature. It overlaps quite a bit. Here's just another example showing the same thing. Sunspots and global temperatures. They correlate very well. Our own Army knows this. Army. Sun, not man, is causing climate change. I can't believe it took them that long to figure this one out. Scientists blame sun for global warming, not CO2. All right. Now let's take a look. The other thing you want to take a look at when you're doing a scientific experiment is how do you measure something, right? And here's two ways that we measure it. One, you can have a satellite that comes down and takes a picture of or temperature or whatever, and it gives it a broad spectrum. And it shows over all the entire area. Or you can do like a little spot measurement, like a little thermometer right here. All right? And this thermometer, by the way, just happens to be above a grill. All right? And that's not a joke. Now, if I was going to ask you, which one do you think is going to give you a far more accurate measurement of a global temperature, little tiny spot things like this, or a satellite? That's satellite, more than likely, right? That's what I would say. I would say the satellite. Right? Well, what does NASA say about these satellite measurements? Sure enough, they say that recently much scientific debate has focused on the global temperatures of the Earth's lower atmosphere as measured by orbiting satellites. And while this data is exceedingly precise, verified by multiple satellite observations and balloon measurements taken in situ, they revealed no discernible warming trend in the Earth's lower atmosphere over the last 18 plus years. That was back in 1997. Tack on another decade, so that's almost 3 decades with no warming, according to the most accurate measurements they have for measuring temperatures. Okay? Here's what they do with the ground measurements. Why I say there's a problem with these ground measurements is this is the difference between the raw and the final data used by these ground measurements. NASA and NOAA take this data and then they massage it. And what they found is that over time, they notice that they've introduced a bias, an upward bias, in the temperature measurements. So they don't just take the data and say, okay, the data is this. They say, okay, this is the data, and then they bias it upward. And so then they come up with the conclusion that, by the way, you're warming. But once again, that warming data conflicts with the satellite data, and it's biased upwards. Okay? And what data, who relies on this data that comes from the spot measurements? Al Gore and Jim Hansen. So when you hear about these people arguing about the temperature measurements, these are the guys. Al Gore relies on what I would argue the most inaccurate temperature measurements of the Earth. They rely on that data, not the satellite measurements. There's actually a group going around to document this, how bad these temperature measurements are, and I've gone with them to a few of them here in Ohio, and it's awful. I mean, here's one of the temperature the thermometers that they use above an air conditioner. I mean, that cranks out a whole heck of a lot of heat. Here's one on a wall. That one's over there on a brick wall. I saw one. They have a picture of one of them by a methane vent that they burn. So you can see that there's a lot of problems with these ground measurement thermometers. One more principle in science. Okay, you typically look for confirming measurements, right? Let's say I'm going to take the measurement of this room. I might use a mercury thermometer, an alcohol thermometer, and an electronic thermometer. And I'll get 3 data sets. And what you look for is you hope that they're all going along together, but if one of them doesn't, but the other one confirms it, you throw the other one, the one that doesn't, the one that's out, that's called an outlier, you throw it out of the data sets. So here we have 3 data sets. I'm not going to tell you what they are. You got method 1, method 2, and method 3. 2 of these go along very well together, confirming. One of them does not at all. It has an upward bias. Which 2 would you say are confirming measurements? And if you're a real scientist, which 2 methods would you use? 2 and 3, right? Because these 2 go along very closely. This one is the garbage data. It's called an outlier. You throw that one out, you say, I got a clear problem with that one, right? So what do you think these measurements are? You got it, temperatures, okay? The ones that confirm are the satellites and the balloon measurements. That's by far the most accurate measurement. Al Gore chooses not to use that. Jim Hansen chooses not to use that. What do they use? They use the one that has a clear upward bias to it. Now, why would any scientist, when given this kind of data, would sit there and say, you know, I know this is the most accurate method, but I'm not going to use it because this one makes my story? Okay? That's the problem I have with this. This isn't science. This is basically making an argument. Here's basically just a measurement of the divergence between the satellite and the global the ground temperatures, and you can see that the divergence has actually been increasing. Now, put yourself in Jim Hansen's shoes. This is a guy who's in charge of all this. He's looking at his data, and it's saying temperatures are going higher, and he looks at the satellite measurements and saying satellites are staying the same. Yet he makes the conscious decision, I'm sticking with my data, even though it's not confirmed and it's not the most accurate. What kind of a scientist would do that? Okay? The other thing is we get into something called cause and effect. Right? If you have a cause and effect model, what is required? The most important thing that is required is that the cause occurs before the effect, right? I go drinking and then I wake up with a hangover, right? Never in your life would you wake up with a hangover and then blame drinking on what you're going to go drink that evening, right? Doesn't make any sense at all. So the cause must lead the effect. Now, understanding that basic principle, here we have a chart that highlights cause and effect. You have one variable that remains very high for an extended period of time and then drops off, and then you have another variable that just drops off real quick. So this one drops off, this one hangs tight for a minute and then drops off. So it's you go drinking, and then you wake up with a hangover, right? So using that model and using this own chart, which one's the cause and which one's the effect? Which one occurs first? This one, right? This drops off first, and then 800 to 1,600 years later, this one drops off. So if this is a global warming model, the cause, this must be what? CO2, and this one must be what? Temperature. But you're wrong. You got it backwards. This is CO2, and this is temperature. The cause is really temperature drives CO2, not vice versa. They have their model backwards. You know how you always say y equals mx plus b? Well, they have a reverse, so it's x equals my plus b. Basically, what they're saying is you have a hangover, then you go drinking. It doesn't make any sense. And they know about this. If you go to This Is Real Climate, this is one of the most pro-global warming blogs out there, and they keep track of it. They tell you, what does the lag of CO2 behind temperatures and ice core tell us about global warming? Well, it would tell any normal scientist that you got your model backwards, right? And you can prove this yourself. Go pick up any chemistry book ever published and look up Henry's Law. Henry's law is the diffusion of gas in a liquid. You find out every New Year's Eve when you pop open that champagne bottle, what happens? That cork flies out. What happens if you let that thing get real warm? It explodes, right? Take a 7-Up and put it on a burner and turn up the heat. You'll see CO2 will fly out of it. Okay? Well, Henry's law is the diffusion of gas in a liquid. Why CO2 trails temperature is because the sun heats the ocean, and then as the oceans heat, they release CO2. It's outlined in every single chemistry book ever published, and that's why CO2 lags temperature. It doesn't lead it. Okay? All right, well, this is the one that was another one that was kind of interesting. Last year, how many people heard about how we were going to lose the polar ice caps last year? Yeah, we were going to lose the polar ice caps. Polar bears would have nowhere to go, right? That's the headline. All right? Well, here are the polar ice caps. And as you can see, 1996, early 97, mid 97. And those polar ice caps, to me, look like they're disappearing in a big way. But I couldn't care less. Now, why would I not care that we're losing the polar ice caps? Do I just not care about polar bears? Am I some just absolutely mean person? I mean, I'm a cool-hearted person, right? But I'm telling you, I couldn't care less about losing these polar ice caps. You want to know why? Because those polar ice caps are on Mars. We don't have global warming. We have solar system-wide warming. All right? Now let's go back to the point, the key thing at hand. Here's a chart of something. I'm not telling you what it is. But it goes up here. It looks like it peaks out around 24. Right? And it's a time frame. Goes from 1979 to current. Right? Now remember, we were going to lose the polar ice caps. Right? Would anyone looking at this chart say that we're near zero at any time on this chart? Anywhere? Do we ever get down here? Anywhere? Right? Now remember, this is the current level. We're at 22. Over here in 79, we're at 22. Okay? So would anyone say, actually, would you say that's almost near a peak? Would anyone disagree with me when I say that's almost near a peak? Okay, so what is this? That's global sea ice, all right? Okay? We're not losing sea ice. We're actually back where we were in 1979. All right? And that's their own chart. But most of the focus was on the North Pole. Well, take a look at the North Pole. NASA does a great job documenting this stuff. You can go back and get every single year, every single month to take a look. And this was 1980. You have to ignore the white part because this is a new enhancement. What you're looking at here is the purple area here and how dense it is. Okay? They look pretty similar, right? That's 1980. That's 2008. There's essentially no change. That's the North Pole. Okay? If you take a look, you can actually get a measurement of the North Sea Pole. And sure enough, last year we did dip a little bit below where we were previously. And they're making a big stink about it, right? But remember what it said. 2008 was the coldest year of the decade. So the coldest year of the decade was causing us to lose North Pole. And 1998, by all measurements, was the warmest. And we had far more ice during the warmest year. Does that make any sense at all? Why are we losing ice as it gets cold? That's their data. All right? Well, why do you think? Maybe it could be that you got a bunch of volcanoes up underneath this ice and they're getting active, right? Okay? There's a fiery face of the Arctic depth. Volcanoes erupting beneath the Arctic ice. And they can't figure out why you're losing ice. Right? The other thing is, why was that other chart near an all-time record high? We were losing, sure, we lost a little bit of ice in the North Pole. We set a record in the southern hemisphere. So how could global warming cause you to lose ice in one area and gain it in another area? That doesn't make any sense, at least not to me. Southern hemisphere sea ice reaches record maximum. A record maximum during global warming, does that make sense? And here's what's going on. Southern hemisphere, you're gaining ice. Northern hemisphere, you lose a little bit. But how could you blame that on global warming? Okay? Well, here's part of the reason. As I've said, if you take a look at it, you take a thermogram. This is Antarctica. What do you notice? These are the warm areas. These are the blue areas. Does that look like it's global warming, or does it look like you have hot spots? Okay? And guess what happens when you look at what's underneath those hot spots? Okay? Giant volcanoes. Antarctica and all these areas are on the ring of fire. We have all this tremendous volcanic activity heating the oceans around those areas. And so when they point out the Larsen B shelf and things like that, well, take a look underneath it. There's a giant volcano. Some people aren't aware of this one. You know how they always say about you're losing all this ice down in Antarctica? Antarctica loses a huge amount of ice on an annual basis. This is the outer limits during the winter. These are the inner limits during the summertime. Antarctica literally doubles in size every year, and then it loses it all back. So yeah, you're losing Arctic ice continually on an annual basis, right? And they know about this. Here's one of the photos that I was able to dig up, and they point out melt fissure from hot water from volcano. Al Gore's not out there telling you Larsen B's dropping off because of volcano. He's telling you it's global warming. Just go digging and you'll find that they label their own charts that way. All right, here's one more. Right? Would anyone, this goes back to 1980. Okay? Would anyone describe, this is the level of 1980, this is the level today. Okay, so I'm going back here, up, this is 80, that's today. Would anyone describe today's level as being higher than 1980? And this is pretty, just follow this right across. This is 1980's level, and that's today. Clearly, this is below it. Okay? Would anyone describe this as sharply increasing, at least from 1992? Okay? 92, 98, 05. Basically have a series of declining peaks, right? That defines a downtrend, right? So would you say it's increasing? Would anyone tell me this chart is increasing in any way? No. Okay? Well, what is this? That's hurricanes. This is accumulated cyclone energy. Hurricanes have actually been getting weaker and less frequent. In fact, we just hit a 30-year low for Northern Hemisphere tropical cyclone activity. And remember, this is the Northern Hemisphere that's warning. I just showed you at the beginning of the show, Barack Obama tell you that we're getting worse in every single hurricane season. I don't know where he gets his data. Okay? But there's the facts. Take a look at it yourself. I have another chart that goes back to 1950, and we're way below where we were in 1950. Well, here's one of my favorite ones. Okay, this one goes back to 65. Paul, you may not like this one. This is 2006. All right. Would anyone describe this chart as decreasing? I cannot see any way you would describe this as decreasing. But I'm going to let you decide. I think everybody would say we're way above 1965. This is 10,000. It got all the way up to up to 30,000. Okay, 30,000 back in 1996 and 98, which, by the way, were the warmest years. So we all can agree that this is an increasing chart, whatever it is, right? Who wants to take a guess at what this chart is? Now remember, this is the warming period, according to NASA's data. This is a warming period, and whatever this is, it's increasing during that warming period. Would anyone disagree with that? That's your polar bear population, all right? Polar bears love warming, believe it or not, okay? Okay? So as you can see, you go up there and they actually say, what blows my mind is they're always making these studies as if no one can ever go verify what they say. They do studies on this stuff, okay? Only 2 out of 13 of these polar bear pods, or whatever they're called, have been decreasing. 11 out of 13 have been either increasing or stable. And we're hitting record high levels of polar bears. They're estimated 20 to 25,000. That's way above where they used to be. Okay? Polar bears love this warming. Right? Polar bears thrive when the Arctic warms up. And that just simply makes sense. They have an easier time hibernating. There's more food typically thrives.
But is it warming or not?
I would say, according to satellite measurements, it's not warming. The most accurate measurement out there shows no warming. I would argue that we're going into an ice age. And that's what the prod is saying. That's what almost all data shows. Okay, so polar bears thrive during warming. Oh, I forgot. Oh, here, this is the quote I wanted to read. So-called warming, yeah. Yeah, you're right. This is the quote of the week. It comes from Bjorn Longberg. He said, polar bears would stand a greater chance of avoiding extinction if people stopped shooting them than if we reduce our greenhouse gases. You can, in my other presentation, I show you that you can actually go hunt polar bears, which I think is awful. But okay, here's another one. This is one of my favorite ones. This shows you how you can lie with pictures. All right? We've all seen those pictures of disappearing glaciers, right? And the big one that they use is Kilimanjaro. That's the big one that grabs the headlines. Now, if I was going to tell you that Kilimanjaro's glaciers are melting, what is the one thing you would have to show for anything to be melting? You got to show the temperatures are actually above freezing, right? Well, once again, you can measure this. You can go to up 19,000 feet, and it never, ever, ever gets below freezing. And they point this out. They know this. Yeah, temperatures never get above freezing. So you're up 19,000 feet. That's like flying in a jet. This is very cold temperatures up there. It never gets above freezing when you're on top of Kilimanjaro. Okay? But they'll tell you that the glaciers are disappearing due to global warming. This is probably one of the most famous photos you'll ever see. This is a melting glacier, right? That's what you're being told. Has anyone ever told you these glaciers are disappearing for any reason other than melting? I mean, or am I being ridiculous?
Sublimation.
Oh, okay. Yeah, you got ahead of me. What's going on here? If this was a melting glacier, and this guy's pointing out, by the way, he's making the case that this is a melting glacier. If this was a melting glacier, what would he be standing in? Mud. This is bone dry. This is freeze-dried area. As Molly pointed out, this glacier isn't melting. It's sublimation. It's a solid to a gas. It's the same process as freeze-drying. All right, here's another chart. All right, this goes back to 1900, 20, 40, today. Would anyone describe today's level, and the way to view these is just simply follow the moving average, this blue line. Okay, the blue line back in about 1910 is 2. The current blue level is about maybe 1. Right? So would anyone describe this chart as increasing over the last 100 or so years? No. Right? Matter of fact, we're below where we were in 20, in 40, in 60, and in 80. A decade ago. So clearly, the current levels are way low relative to a historic basis. Well, what is this chart? It's the sea level. It's the rate of sea level increase. Okay? So our sea levels aren't increasing at a greater rate than ever before in history. According to our own chart going back 100 years, we're barely increasing at all. More importantly, is take a look over here and how this is measured. Now, this is a rate of increase. This is measured in millimeters per year. You want to know how many years at growing at less than a millimeter a year it's going to take to flood Manhattan? All right? Believe me, we're not going to be around. Okay? And it's nothing, it's nothing spectacular. The rate of increase is actually decreasing according to their charts. More importantly, what exactly is sea level? You have sea levels, and this is the measure of sea level. You can see this is where it's shrinking or falling, and that's where it's increasing. If you take a look, you have areas where you have falling sea level and increasing sea level. Ironically, if you look right off of Manhattan, that's the area that has falling sea level. You're actually probably gaining land in Manhattan, according to Colorado Center of Astrodynamics and Research. This is the sea level rise. Right? The other claim was famine. Now, this one I've never understood at all, because typically with global warming, civilization thrived as we came out of the Ice Age, right? You didn't have great civilizations during the Ice Age because nothing would grow. Nothing grows in ice. So as the Earth warmed coming out of the Ice Age, that's when civilizations thrived. They could feed themselves. That's when Fertile Crescent developed, right? But I'm being told that we have record famine and stuff, right? Well, record famine to me says that people are starving. How can you have people starving when you have world record wheat production, right? This doesn't make any sense. You're literally producing more food today than ever before in history. Record food production in India. Okay? Global food crisis, strong signs of record rice production. You can't find a crop that's not hitting a record last year, and yet we're having people die of famine. It's certainly not due to global warming or decreasing food production. And why is that? Because believe it or not, with increased CO2, crop yields actually increase. If you're growing something, you want higher CO2 production. Matter of fact, next time you go in a greenhouse, look for something like this. Everybody in the agricultural field understands this. They sell these things. Go in there, look in a greenhouse, and you'll see something like, you want to know what this is? A CO2 generator. They've deliberately increased CO2 in greenhouses. Right? All right, here's one of the things that I think most people, why I get kind of concerned, why I'm really concerned about this, is what they're using all this global warming stuff for. It's basically going to be used for passing legislation for one thing or another. But the problem with that is CO2 is the basis of life. If you take organic chemistry is the study of carbon, right? Carbon forms the backbone of biology of all life on Earth. Right? We are carbon-based life, and we have certain groups out there tell the EPA to regulate CO2 as a pollutant. What I am exhaling right now could become a pollutant. Right? And it doesn't take, you can just start to think what could possibly happen then. All right, here's one more chart. When you're looking at a data set, you're going through and you typically try to find things that look a little bit abnormal. Well, here's one called a tipping point. And I have something being measured here and something being measured here. And as you can see, it looks like it falls off the cliff here. And as this fell off the cliff, this shot up. Right? Would anyone disagree with that? So if I was going to ask you what's the tipping point, what year is the tipping point on this chart? 1990. Bravo. All right? Okay, well, I'm sitting here saying, well, what exactly is that? That's the number of weather stations and the temperature. So clearly in 1990, a large number of weather stations just were removed from the map, and temperatures suddenly shot up. Does that make sense? So if you're making the case that you're undergoing global warming, do you think they removed weather stations from the warm areas or the cold areas? The cold areas. That's what I would think, right? But then I'm scratching my head. Well, what happened in 1990 that would remove a great deal of cold weather stations? What happened in 1990? Fall of the Berlin Wall, right? Russia collapsed. All those weather stations up in Siberia were closed, all right? They closed, and then lo and behold, temperature suddenly shot through the roof. Russia's back in the news because they gave Hansen the bad numbers recently that made a NASA report the bad numbers again because they gave summer numbers for winter. Okay? Here's the other thing about the weather stations. You can see that we have a large number of weather stations all over the place. They're all colored differently because they all are a different quality. So you're taking all these different quality temperature scales and putting them together. Not very good. The other thing is impartiality. You got to be worried about when you're doing some kind of a scientific experiment. Well, this is Jim Hansen. This is the guy who basically has the keys to the kingdom. He has Barack Obama's ear. He has Al Gore's ear. And who is this guy? This guy went over to England to defend some eco-terrorists recently and was able to get them released. Okay? I would not call this guy a very impartial guy. This guy is a firm believer in global warming. He controls the data. He's the guy who's made 2 major errors in data. By the way, have you ever heard of this is NASA. These are the rocket scientists. Have you ever heard anyone making a mistake twice and keeping their job? He's blown the data twice in a big way, and he's kept his job. Deja vu, and this is just an article that talks about how he's messed the data up twice and he keeps his job. Right? And this is basically a chart that just represents what I mean by the rewriting history. This is the unadjusted data. This is the adjusted data. Jim Hansen goes back and applies this computer algorithm to historical data, and he changes it. And you can see this was unadjusted, this is adjusted, this is unadjusted, this is adjusted. And guess what? It keeps going higher. He biases the data upward. Same thing with NOAA. This is NOAA unadjusted, and this is NOAA adjusted. They bias the data higher. Now, I saw that, and I thought, that's got to be a joke. We're running out of time. Well, I thought this has got to be a joke. Well, I went back, and sure enough, they even publish the errors that they make. And you can go take a look at the data. They do actually adjust the data. You can read a little bit more about it in this one. Just to wrap things up here, this just simply goes back to when I was a kid. If you remember when you were a kid, I was being told there's a coming ice age. As you can see, they go back and they say, remember the global cooling? Okay. Now we're 30, 40 years later, it's global warming. You also probably remember the ozone hole. The ozone hole, 40 years after we banned CFCs, is making all-time highs. Now, I could cover the economics of it, but we won't do that today. That's all, folks. Thanks for listening.